Good day everyone. Today I will be discussing about passive filter and integrated circuit. These are important because they help control signals in electronic devices like radios, audio system and communication circuit. First, let's define what is passive filter. A passive filter is a circuit that uses only a passive components such as resistor, capacitor, and sometimes inductor to control our filter signal. So, passive filters don't require an external power supply because there are no amplifiers. Instead, they use passive components which include resistor, capacitor, and inductors. However, because a passive filter doesn't use external power, this means that it cannot produce any power gain. A passive filter has an incredibly simple design, making it fairly inexpensive. Since they use inductors, a passive filter can handle very high currents, making them suitable for high frequency applications. Passive filters are most commonly used in audio applications, specifically for speaker system, to direct lower frequency bass levels to the larger speakers. And now let's proceed to the important details about passive filters. Number one is no power supply. Passive filters do not need external power. They only use the input signal. Second, no amplification. They cannot increase the signal strength, they only reduce or pass certain signals. Third is use in integrated circuits. In ICs, passive filters usually use resistors and capacitors only. Inductors are rarely used because they are large and hard to integrate. And lastly, simple and low cost. They are easy to design and less expensive compared to active filters. So, let's move on to the types of passive filters. So, first type of filter is low pass filter. A low pass filter allows frequency signal to pass and blocks high frequency signals. For example, it can be used to remove noise in audio. Second type is high pass filter. A high-pass filter allows frequency signals to pass and blocks low-frequency signals. For example, it removes bass sounds. And the third type of pass filter is band-pass filter. A band-pass filter allows only a specific range of frequencies to pass. It blocks both low and high frequencies outside the range. This is used in radio tuning. And the last type of passive filter is band stop filter. A band stop filter blocks a specific range of frequencies and allows low and high frequencies to pass. It is used to remove unwanted signals or noise. And now, let's talk about the limitation of passive filter in integrated circuit. So number one limitation is cannot amplify signals. It can only block or reduce parts of a signal, but it has no power source to make the signal stronger. Second limitation is signal may become weaker. The signal loses some energy when it passes through resistors, inductors, or capacitor, so the output is smaller than the input. The last limitation of passive filter is less accurate compared to active filter. It can't filter to frequencies as sharply or precisely because it doesn't use operation amps or transistors to control the response. Now, let's move to application of passive filters. So first is noise reduction. It removes unwanted electrical noise or interference from a signal so the circuit works more cleanly. Second is signal filtering in circuits. It blocks or allows specific frequencies to pass through, like keeping low frequencies and removing high ones. Third is basic audio filtering. It is used in speaking or headphones to control bass and treble by cutting off sounds that are too low or too high. These formulas are all you use in passive filters because they tell you how resistor, capacitors, and inductors control which frequencies pass or get blocked. So first formula is the cut-off frequency. So this finds the frequency where an RC Low pass or high pass filter starts reducing the signal. Second formula is the angular frequency. So, kay bawo naman ta unsay formula sa angular frequency. So, this converts the cutoff frequency from hertz to rad per second. So you can use it in AC circuit equation. Third is inductive filters. So, this give the cutoff or resonant frequency or LC and RLC filters that use both inductors and capacitors. Fourth is the capacitive reactance. This shows how much a capacitor's block AC current, which changes with frequency and is key to how it filters. Fifth is the inductive reactance. This shows how much an inductor blocks AC current, which increases with frequency and is key to how it filters. The last is the voltage gain. This measures how much the filter reduces the signal. Because passive filters have no power source and can only make signals weaker or not stronger. Passive filters are just made of R resistor, L inductor, and C capacitor components, which no amplification. So to design them, you only need to calculate where they cut off, how each part resists EC at different frequencies, and how much signal is left in the output.
So, naata example problem. Example problem number 1. Determine the gain of an active non-inverting amplifier with RF is equals to 10 kilo ohm and R1 is equals to 5 kilo ohm. So to solve this problem, we use the formula of voltage gain is equals to 1 plus RF over R1. So guys, basin mahibong mo ba nga nung nay 1 diha nga formula raman unta sa voltage gain kay voltage gain is equals to voltage out over voltage in. So ang kana ding 1 diha kay nagrepresent na siya sa direct connection of the input signal to the output. So ang kanang 1 mao na siya ang original signal. Nya ang kanang plus kay additional gain from the resistor. So mao nang the total gain becomes AV is equals to 1 plus RF over R1, combining the original signal and the amplified portion. So ato na i-substitute ang mga given ato sa formula. So 1 plus 10 kilo ohm over 5 kilo ohm. So our voltage gain is equals to 3. This means the output voltage is 3 times larger than the input voltage. So here is the another example. Example number 2. Calculate the cutoff frequency if R is equals to 500 ohm and C is equals to 2 microfarad. So to solve this problem, we use the formula of cutoff frequency, which is Fc is equals to 1 over 2 pi Rc, where ang resistor na to kay 500 ohms, nya ang capacitor to ay 2 microfarad. After na to substitute sa mga values, nakakuha tag result nga 159.15 Hz.
Good day everyone. So now I'm going to discuss about the active filter in integrated circuits. So what is an active filter? So an active filter is a circuit that uses an operational amplifier, resistor, and capacitor to filter signals. It needs a power supply and can amplify signals. Furthermore, active filters are a type of electronic filter that uses active components, including op-amps and transistors. They actually work with passive components as well, like resistors and capacitors, but not inductors. So compared to passive filters, their designs is complex and they tend to be more expensive. So we have here a types of active filter. First, active low pass filter. So an active low pass filter allows low frequency signals and also amplifies the output. Next, active high pass filter. An active high pass filter allows high frequency signals and amplifies them. Third, an active bandpass filter. So an active bandpass filter, it allows a certain range of frequencies and increases the signal strength. Lastly, an active bandstop filter. So an active bandstop filter blocks a specific range of frequencies while still amplifying the remaining signal. So we can apply these active filters in audio system, communication circuits, signal processing, and instrumentation. So now let's talk about the advantages of an active filter. First, it can amplify signals. Second, more accurate and stable. Third, no inductors needed, which is suitable for ICs. And lastly, wide range of frequency selection. So now let's move to the formulas. So for op amp gain non-inverting, AV is equals to 1 plus feedback resistor over input resistor. Then for op amp gain inverting, AV is equals to negative RF over Rin. For bandpass center frequency, it is equals to 1 over 2 pi RC. And for quality factor, it is bandpass center frequency over bandwidth. And for bandwidth, it is upper cutoff minus lower cutoff. So for important details, an active filter needs a power supply positive V and negative V. So it uses an op amp with resistors and capacitor, can amplify signals, does not need inductors, which make it good for IC design, and it is more accurate and stable compared to passive filter.
Here is another example problem. Example number 1. Compute the bandwidth if f1 is equals to 200 Hz and f2 is equals to 1200 Hz. So, ang bandwidth di ay kay nag-define siya sa differences between the upper frequency or f2 ug ang lower frequency which is ang f1. So, to solve this problem, we use the formula of bandwidth or BW is equals to upper frequency f2 minus lower frequency f1. So, 1200 Hz minus 200 Hz. So, ang bandwidth nato kay is equals to 1000 Hz. So, here is another example. Example number 2. Find the quality factor Q if FO is equals to 1000 Hz and BW is equals to 200 Hz. To solve this problem, we use the formula of Q is equals to FO over BW, where resonant frequency FO is equals to 1000 Hz and bandwidth or BW is equals to 200 Hz. So, ang Q na to is equals to 5. Kung mahibong mo nga nung wala siya unit kay pareho mo sila hertz nya makancel na siya wanang unitless siya.